Okay, let's talk about a substance that's so common we barely even think about it. But when you start to list its properties, well, it sounds absolutely terrifying.
Get this, its inhalation can be fatal. It's a major greenhouse gas, and it's also a powerful solvent that's used all over the chemical industry.
And there's more. It's the main ingredient in acid rain. You find it in high concentrations at industrial disaster sites, and even after you wash it away, traces of it will always remain.
So what is this incredibly dangerous, pervasive chemical that I'm describing? Any guesses?
Yep, it's just water, H2O. And as you're about to see, this everyday substance we think we know so well is actually one of the strangest, most mysterious things on our planet, with some truly bizarre properties that are absolutely essential for our existence.
All right, let's dive into some of the scientifically proven weirdness of water. So, first up, something you've probably seen a million times, but maybe never really thought about. For almost everything else in the universe, when it freezes, the solid version is heavier, it's denser than the liquid, so it sinks. But water breaks the rules. Ice is actually less dense, which is why it floats.
And it's a good thing it does, because this one little quirk is, well, it's everything. That floating layer of ice acts like a blanket, insulating lakes and rivers during the winter. It keeps them from freezing solid from the bottom up, which protects all the life underneath. Honestly, if ice sank, our oceans might have frozen completely, and life might never have gotten started.
Okay, now for another really weird one. If you look at molecules that are chemically similar to water, like hydrogen sulfide, you see a clear trend. Based on that trend, water should boil at something like minus 100 degrees Celsius. It should be a gas at room temperature. But nope, it boils at a crazy high 100 degrees Celsius. And that ridiculously high boiling point, that's the whole reason we're here. Its liquid state is the perfect playground for all the complex molecules of life to bump into each other, react, and create, well, us. Without liquid water, biology as we know it just wouldn't work.
Okay, so the physics are weird, but water's power goes so much deeper than that. It's woven into the very fabric of our consciousness. Think about it. In pretty much every culture, water is seen as the ultimate source of life. It's used for spiritual cleansing, in rituals from baptism to ablutions. It symbolizes rebirth, renewal, our deepest emotions, and our intuition. It's almost like water is a mirror for our own inner world. And this is where things get really fascinating. And let's be honest, a little controversial. We're diving into the idea that water can actually hold information, that it has a kind of memory. So here's the big question. Can water actually react to our thoughts and our feelings? This is the wild idea that was explored by a Japanese researcher named Masaru Emoto. So Emoto did these famous experiments. The idea was simple. He'd expose water to different things. Positive words like love and thank you, or negative ones. Then he'd freeze the water and look at the ice crystals under a microscope. And he claimed that the water exposed to positive intentions formed these beautiful, complex, symmetrical crystals. The water exposed to negativity, it formed these ugly, broken, chaotic shapes. Now, I have to be clear here. These pictures are, wow, they're compelling. But mainstream science is not on board with this. Emoto's work hasn't been replicated in a way that satisfies the scientific community, so it's still seen as highly controversial. But he wasn't the only one exploring these ideas. This is where we get into the really heavy scientific debate, with guys like Jacques Benveniste and later even a Nobel Prize winner, Luc Montagnier, who you might know as the co-discoverer of the HIV virus. So back in the 80s, this respected biologist, Jacques Benveniste, he drops a bombshell. He claims that water can remember a substance it's been in contact with, even after you've diluted it so much that there isn't a single molecule of the original substance left. Okay, stick with me here, because Montagnier took this idea and ran with it, conducting an experiment that sounds like it's straight out of science fiction. Here's how it went down. First, they took water with DNA in it and diluted it over and over until it was statistically impossible for any DNA to be left. Just water. Second, they recorded a very faint electromagnetic signal coming from that informed water. Third, they digitized that signal and, get this, emailed it to another lab. And finally, at that second lab, they took a tube of totally pure water and just played the signal to it. Then they tried to rebuild the original DNA out of that water. And the results? The DNA they built from scratch was a 98% match to the original. Think about that. It's like they teleported the information of the DNA over the internet, and the water in the other lab just built it. This flies in the face of everything we think we know about biology, which says you need physical molecules to touch for anything to happen. You can probably guess what happened next. The scientific community, well, they freaked out. As Montaigne himself said, there was this intellectual terror. If you even dabbled in this stuff, you were basically an outcast. Why? Because this suggests biology isn't just chemistry. It might also be physics, about frequencies, information, and that changes everything. So why? Why would a Nobel laureate risk his entire reputation on such a radical and frankly unbelievable idea? Because he saw a potential future for medicine that was absolutely staggering. Just imagine, if water can hold the electromagnetic signature of DNA, maybe we could detect diseases like Alzheimer's or Parkinson's just from the signals in our blood, long before symptoms appear. And here's the big one. What if we could treat illnesses not with chemical drugs, but by transmitting the right healing frequencies directly to the water in our own bodies? We're talking about creating low-cost digital medicine. So it leaves us with this huge question. What exactly is water? Is it just H2O, a simple molecule with some quirky physics? Or could it be something more, a liquid crystal, a biological hard drive that stores information, responds to our intentions, and maybe even mirrors the cosmos? The honest answer is, we just don't know. And perhaps the greatest secret of water is how much we still have left to discover.